Hello and welcome to the final episode this term of Artificial Intelligence and Us, a speaker series from Warwick AI. My name's Joe and I run the speaker series at Warwick Artificial Intelligence Society. So, who are we? Warwick AI is a student-run collective of students passionate about artificial intelligence and its impacts on humanity. We offer courses, we run projects with real-world impact. We host talks with world-leading professionals, and we help you find a career in artificial intelligence. If you're interested in finding out more about Warwick AI Society, then check out our website at warwickai.mn.co or find us on Instagram. We're actively recruiting at the moment for a couple of new positions, so please do send us a DM if you're interested. So without further ado, I want to introduce today's speaker. Stuart Armstrong is a researcher at the Future of Humanity Institute at Oxford. In the past, he's worked with the Machine Intelligence Research Institute at Berkeley in California. So, in our lifetimes, the trajectory of humanity has shifted. The advent of machine intelligence has introduced an unprecedented uncertainty, and it's become an increasingly more difficult problem to try and work out where we're going and where we're going to end up down the line. The future is going to be extraordinary, and at this present moment, we can hardly grapple with it. But Stuart's research entails confronting this uncertainty. He's published a massive literature, and he's trying to map out this future and figure out how we can safely introduce advanced machine intelligence into our world. Without further ado, I want to pass over to Stuart Armstrong. Thank you, Stuart, so much for being here.
Thanks for inviting me. Now, is everyone hearing? I'm not actually seeing any more people in the feed.
No, so we're streaming this one live to YouTube.
Oh, okay. So anyway, so I hope I hope the people who can't talk back to me now are hearing all this. And now let's get to the talk. And right. Okay, so thanks for inviting me here. And my claim here is that every problem in AI is out of distribution behavior. Notice the key asterisks around there. Now, when an older professor type tells people that everything is reducible to their one pet theory, this is a good reason to be dubious of their claims. But I'm hoping to convince you that at least to some level, all problems in advanced AI are at least related to out-of-distribution behavior. But before getting too technical, I thought I'd just start with an overview of the arguments for or against potentially extremely dangerous and powerful AIs, because this is an area in which there is a lot of poor thinking and very few quality arguments for some very good reasons. Here are some of the old predictions. This is the Dartmouth conference that started the field, and they were basically predicting that we would have AI over a summer's work. Now, I've done what very few people have done, which is to look at their original paper, their proposal, and read it, and it was very good. They sketched out different avenues of research, they saw some of the problems that would happen and how it could be dealt with, and this was done by some of the smartest people in the world at the time, and not only theory, but at practice of getting computers to do what they wanted to. So fantastic pedigree, very well thought out, and disastrously wrong in terms of its expectations. 9 years later, Dreyfus, in an otherwise excellent paper that might have got more attention if he hadn't compared AI researchers to alchemists, but he was suggesting that the limit of what computers could do was pretty much been reached. Now, it's safe to say that neither of these predictions is particularly correct, but most predictions in AI are incorrect, and we know that because they contradict each other. The term AI is very slippery, and it's not clear always what it means. But here's a bunch of things that were predicted to be roughly AI-ish, made at various times by various people, the date at which they were expecting it to arrive. Here is Turing's original prediction, and here is the AI winter, where everyone was pretending that they weren't working on AI anymore. And as you can see, there's no real pattern. There's a bit of an accumulation on the 2030 in the recent predictions, but this seems to be more of an artifact that people tend to predict things 15 to 25 years into the future for when AI will finally arrive. Apart from that, they're just sort of spread out all over the place. And this is what we should actually expect, because we actually have data as to when experts are good and when they're poor at prediction tasks. And it has very little to do with the quality of the expert and a lot to do with the task they're accomplishing. This is from Shanto's Competence in Experts, the role of task characteristics. And basically, tasks that have the features on the left are the kind of things where we expect good expert performance. And tasks which have the features on the right are the kind of things where we expect poor expert performance. The most important ones are expert agreement or disagreement, whether the problem's decomposable or not, and above all else, whether there is feedback available, preferably immediate feedback. It's for this reason that anesthesiologists are true experts and doctors who interpret mammograms are not. I choose these examples because they're roughly equivalent in terms of study needed to become good at that. The anesthesiologist gets immediate feedback. Their patient is either not unconscious or dead, and that tends to be rapidly noticed, whereas the ones who interpret mammograms may discover much later whether they were right or not, or may not even know at all. Now, when it comes to predicting AI, the sort of smart, human comparable AI that the term meant in the 80s and 90s, we're kind of stuck on these areas. So we should expect poor performance on expert predictions, and that is indeed what we see. Now, there are lots of arguments as to why AI might be very powerful and dangerous, or not powerful and not particularly dangerous. And the two sides of the coin tend to be whether we look at AI as a typical technology or a unique advance. If we look at AI as a typical technology, here it's on the civilization tech tree along with space colonization and nanotech and a few other things, then we tend to find that we shouldn't expect it to be anything stunningly revolutionary or anything that we can't cope with. When we focus in specifically on AI, on the details of the technology, those arguments tend to point towards it being very powerful and potentially very dangerous. This is sometimes known as the outside view, where you look at it as a typical technology, or the inside view, where you look at the specific details. Both of these approaches have different track records in different areas. So if we look at the outside view, well, revolutionary predictions don't generally pan out the way that you would expect. Things change, things might change in a revolutionary way, but they tend to change gradually, partially, and not in the simplistic way that we'd expect. The predictions on technology has a particularly poor track record. And even if we go back in time, here is Queen Elizabeth I banning or denying a patent to a simple knitting machine because of the risks of unemployment. So that has been a perennial problem since forever. There's the technological peace theory, which was arguing that basically more technology means more peace. This to put it mildly, has not exactly got a perfect track record, though there is some evidence that it might be happening today. But the simplistic version of this, the sort of grand breakthrough, is generally incorrect. So we should beware of revolutionary predictions. If you want to imagine it more personally, take an iPhone and imagine talking to yourself 15 years ago and telling them all the things you could do with your new smartphones, and then ask them to guess what would be different and what would be the same as today as compared with then. I pretty much don't think that they would get the things right. They would not expect the explosion of disinformation and resurgence in nationalisms and other trends that seem to be counteracted, that did not seem to be expected with a device that can give you so much factual information. The other reason to beware of predictions of AI doom is that interventions derail predictions. The millennium bug can be mocked for not being nearly as bad as we expected, but the reason it wasn't nearly as bad is because we acted on it. There was a lot of computer experts spent a lot of time, and that reason the millennium bug didn't happen was because of all that effort. Tom Lehrer was doing a song called Who's Next about which country would get nuclear arms next in a period where proliferation seemed to be exploding all over the place. And it ends with the great line, and we'll all try and stay serene and calm when Alabama gets the bomb. But at about the time that he was singing this, they signed the Non-Proliferation Treaty, which had a noticeable effect on the rate at which new countries are getting technologies. So we're roughly around 10 at the moment, which was a lot less than what was expected. So interventions can work. And there are other things, is that any sort of technology or advance tends to breed its own resistance, or any danger similarly breeds its own resistance. And a very current example, viruses start by spreading very easily through the vulnerable targets, and then either people adapt their behavior or they just run out of vulnerable targets. So later on, it's harder and harder to get the last few victims. And so any sort of technology would be self-limiting. In general, when people talk, so in general, the very bad predictions are made when they have apocalyptic or utopian mindsets. And AI is both. AI is a utopia and an apocalypse. And we tend to think very poorly when we're thinking in those terms, which is one of the reasons that I don't like the term singularity, because I think it obscures more than it helps. Now, this is the general argument for why things that look like AI, I just want to make a last point that don't go too far on these things. You can't figure out technological developments by looking at human psychology. Just because apocalyptic or utopian thinking is often wrong doesn't tell you really that much about what's going to happen for technical AI progress in 20 years' time. It just tells you to look carefully at the argument. And if we now look at the more specific, so these are the general arguments for AI-like things, revolutionary technologies, probably not going to be what they say. But what about AI specifically? Well, if we take the inside view, intelligence is a superpower. This is a chimp brain on the left and the human brain on the right. They're pretty similar, a bit different in size, but chimps have a population in the hundreds of thousands and can use basic wooden tools. We number in the billions. We're spread out all over the planet, and we have heavy industry and nuclear weapons. And ever since we've extended our minds with computers, we've done things like walking on the moon getting hydrogen weapons, and having unprecedented economic growth. At the moment, chimps survive on human sufferance. Chimps are being hunted by humans, chimps are being protected by humans, and the survival of the chimp population is basically dependent on the balance between those forces rather than anything much that the chimpanzees can do. So gains in intelligence can result in huge differences in power. And we can also imagine that, well, what could we do with human-like intelligence? We could also ask what we could do with human-like intelligence in computer format. So if we had something that's comparable with a human, we could copy it a few times and then train it, and then get the AI equivalent of Edison, Einstein, J.K. Rowling, Thatcher, Oprah, Confucius, Goebbels, Steve Jobs, and Bernie Madoff. All of these are humans who are cognitively brilliant in their particular area of expertise. We create their AI equivalents, we give them access to vast amounts of data, and we run them at thousands and thousands of times human speeds so that they have a subjective week to think of any of their answers. For this sort of super committee of AI, it's likely to find that the human race and the internet are useful resources for its goals. And this is the kind of thing that we can create with human level AI, if we ever got that. Similarly, the fact that AI is copyable is a unique potential increase in power. Corporations are some of the most powerful entities in the world today, and apart from capital, their main assets tends to be their people, their structure, their organization. But if we had an AI, we can create such a thing very quickly, just through copying. No need to hire, no need to train, no need to manage them to any great extent, because all the incentives would be aligned if we did it properly. And so just from the power of copying, we can create the non-capital portion of a powerful corporation within a minute. Now, currently there are omega billion computers. I used to have an actual number here, but it kept on changing, and it really depends on what you count as a computer. But for whatever number of computers, we could run a certain number of AIs when we develop them. But of course, these AIs can be used to manufacture and develop technology, so then there would be many more computers and many more potential AIs. So a world in which, say, for example, there are 1,000 smart super committee AIs for every human on the planet, and these AIs can coordinate amongst themselves very well. This is a world that would be quite different from our own, and where the AIs would likely be in a very powerful position. So here I've just skirted over the outside view. Revolutionary predictions for AI are likely to be wrong because revolutionary predictions for all technology are likely to be wrong. And the inside view, it really seems that AI is different when you zoom in on it. And so there's a lot of uncertainty here. And it sometimes needs to be said that uncertainty means really uncertain. Uncertain doesn't mean jump to which end of the scale that you particularly prefer. On the certain to impossible scales, or the almost certain to almost impossible scales, we can put at one end the laws of math, conservation of energy, and the fact that you won't win the lottery, and their converse, the contradictions of those. These are the kind of things you never quite reach 100 or 0%, but these are the kind of things that you really can be sure are going to happen or not going to happen. Then we have the interesting middle probabilities where most of our lives live. And there are different types of things for the middle probabilities. At first, there's things for which we have no evidence, such as the gender of the first leader of Mars. We don't know when there will be humans on Mars. We don't know when there'll be some sort of political organization there. And we don't know when it'll have a leader. We're not even necessarily sure that there'll be a majority of two genders by the time that happens. So there's no really strong evidence for this. Then there's something that we have weak evidence, like the gender of the US president in 2037. We are pretty sure that that president will be someone that has that is already in politics at the moment, so we might be able to do basic statistics on that. But the evidence that we have is going to be rather weak. And then we have balanced evidence, like the gender of the next US president after Biden. Because Biden has a female vice president, this is uniquely close to 50% based on strong evidence. Where AI is concerned, though, it's mainly no evidence and weak evidence. So there's no real justification in putting it anywhere near the edges. Depending on how the question is phrased, I tend to put it between 30% to 5% chance of an AI existential risk that threatens human survival. And I think it would be arrogant to move too far away from this range. Or yes, I would say that anyone who says that the risk of AI is less than 5% or higher than 95% is wrong and is not properly accounting for uncertainty. Now, this risk is less than 50%, but still, I would not go on an airplane that has a 5% chance of crashing every time it flew. And here we're talking about crashing the Earth, and humanity. So some precautions should still be taken, even if the risk is less than 50%. And this is basically what I've been working on. Right, now we can start looking at some of the solutions. I haven't given you the full AI risk presentation. You can look that up. There's some other presentations on the website, the Future of Humanity Institute website, and in other places. But now let's move on to some of the solutions. The AI risk thesis, condensed to a single sentence, is that AI might be effective at unbounded, unfriendly goals. And the various solutions seek to attack different parts of this. Like there are ways of trying to make it less effective, like a boxed oracle. They're a way of trying to get it bounded so it doesn't sort of massively change the entire future just with a minor goal, like low impact approaches. To attack unfriendly, we can try and get it to the value learning, and we might actually try to think to ensure that it doesn't actually have goals. And then there's the approach that I'm presenting in this paper, which can kind of work for all of these, which is out of distribution, or as I call it, model splintering. So what is this, and why do I think it's relevant for all the issues of AI? Well, the first thing is to note that humans have very strong underdefined preferences. And let's start with nationalism. Nationalism gets quite hard to define when you really get down to it. There's a long book about how you define what a nation is, its people, its ideas, its landmass, or there's lots of essays on this. I'm willing to bet that the vast majority of nationalist people across the world have not read this book, and that the vast majority of those people would be incapable of defining what a nation is with any rigor. But this doesn't mean that they don't have preferences. Like if you know that they're strongly nationalistic for a certain nation, they can answer questions like which flag should they wave, who should they trust, where can these particular people go, and you'd have a good idea of how they would answer these questions. So their nationalism is relevant, even though you can't really define it with any rigor. So and I think this is a general problem with human preferences. It's that it's not that we have it's not that we don't have preferences or that the preferences are incoherent, but that the preferences are very strong but defined in terms of concepts which are themselves incoherent, like a nation. To pick an example, consider a Croatian communist Yugoslav nationalist in the 1980s. The three aspects of their preferences and of their identity are roughly aligned in the 1980s. There's no tension. But of course, there's soon going to be a war, and their identity is going to splinter. And it's not sure which part of it they're going to follow, which is a consideration they never had before, because they would never, the aspects of their preferences were never splintered before. They could think of it as one thing. And very often in history, moral concepts splinter. I'm going to pick on three, one of them which has entirely broken down, one of which is in the process of breaking down, and one which I expect will break down in the future. The first is the importance of honor. There are a lot of cultures that have a strong emotional connection and preference for honor and honorable behavior. But if you look at the Wikipedia page on honor, for example, it looks like a grab bag of random concepts bunged together, like keeping your word, reacting with violence, sexual chastity, and a variety of other factors. And it varies from place to place, all of which would find honor very important, and all of which would tell you, yes, honor is something. And yet the concept has splintered, has broken down. Then there's the Victorian middle class, woman should be protected ideal. And the gender binary has been splintering ever since. Now, nowadays, it's obvious because you start seeing other genders beyond the traditional two. But it's actually been splintering for a long time, because in Victorian middle class England, if you knew someone's gender, you knew how they dressed, you knew what jobs they might have, you knew whether they could vote or not, you knew the inheritance law that applied to them, and so on. And as the years went by, this knowledge will become less and less split. So in the 1960s, knowing someone's gender tells you a lot about them, but it tells you a lot less than it did in Victorian England. And so this concept has been splintering for a long time. However, Victorian men, I am sure there are many Victorian men who really strongly feel something like woman should be protected. And the fact that the concept of woman can become underdefined, and the fact that protected might also become underdefined, doesn't mean that they don't strongly feel this preference. Today, we might feel that happiness is important, but I expect that happiness is going to splinter quite soon as well. We already have hedonic happiness versus other types of happiness, but I think even hedonic happiness or any other type is going to splinter more when we start considering things like identity, continuity of experience, what drugs can do, and whether happiness is genuine. And this is going to become more and more a grab bag of small concepts rather than the single thing that we feel today. Now, here I've been presenting it, the sort of out of distribution or model splintering in terms of morality or preferences. But it's actually a general problem, even in the hardest areas. These are the laws, the ideal gas laws, pressure, temperature, volume, and all of those are related to each other. However, there are some slightly more sophisticated laws, the Van der Waals laws, which also take into account some corrections for different materials and different molecules. And then, of course, There's what happens when you zoom in and have a look at what's going on. Well, these are atoms moving about in various trajectory. And where's the pressure gone? There is basically no pressure at this scale. Pressure is a statistical approximation, but it doesn't exist if you zoom in long enough. That doesn't mean that the ideal gas laws are wrong. It just means that the concepts no longer apply when you can look at individual atomic atoms. And of course, then you can go to quantum effects and then quantum gravity. And in each case, the previous concepts that you have are splintered. So if your previous concept was, if your previous motive for the AI is maintain a pressure of 25 pascals, will it maintain that goal as it delves in deeply and has a deeper understanding of the universe? Now, in these circles, there's often a comparison made between Blegg's and Rube's. This is an example of Eliezer's. Blegg's are blue eggs that glow and are furred and contain vanadium, whereas Rube's are red cubes that don't glow and that are smooth and can contain palladium. And he's using this to illustrate how concepts can change or can be slippery. Now, imagine that we trained an AI on a bunch of Blegs and Rubes, and they managed to classify it into two categories. And this is their main interaction with the world. But it turns out that the human who was doing the training was just noticing the color. They said, let's get some blue things and some red things. The AI was being more detailed, and it classified it on 4 different features. And then it didn't actually classify it on the vanadium-palladium distinction. And then suddenly we're presented with a red, dark, furred egg with vanadium. And if all of the AI's preferences have been specified in terms of the previous, in the training, it has only encountered Rubes and Blegs, then it doesn't really have any way of dealing with this. So to reiterate briefly, the general problem is that you start with a small part of the map, and that's where your preferences are defined. And then you need to make the map as big as the universe and all the possibilities of the universe, and still have these extended in some semi-coherent manner. So to pick an example, I believe Warwick was at some point rather important in English history. The Earl of Warwick, Kingmaker. So we can zoom in on that little part of the world and that little part of history. And there would be some very important concepts that the people of the time used and cared about: money, the harvest, feudal duty, teaching children, etc. All of these things made up their world. Then, if we extend it to the scale of the Earth and a much greater span of history, well, some of these concepts don't make any sense extended across this. Some of them are different, like money is a very common thing, but doesn't mean the same thing in different areas. Hierarchy definitely changes all over the place. So none of them, so their concepts with which they built their world, and if they had an AI with which they would have programmed the AI, start extending very poorly. And then when you extend to the entire universe and all the possibilities that we might explore in that, then they start to make even less sense. So the initial concepts have splintered into many more things. And this is why I call it model splintering, as the concept splinter. And in a sense, the challenge of AI in most areas of advanced AI safety research is to have them deal successfully with these model splintering. I'm going to just end by listing a few areas of AI safety and how they can be seen in terms of model splintering. Don't worry if you haven't met these before. It's mainly for the people who have met them and how they can connect to here. The hidden complexity of wishes was done an thought experiment by Eliezer as to how to get a algorithm to get your mother out of a burning building without hideous things going hideously wrong. Basically, what we want is for the algorithm to save my mother. And the concepts of save and mother are ones that make sense to us in the normal span of our experience. But the AI, if the AI can look outside of that and create far more exotic solutions, then these are underdefined. And the important thing is that these ideas extend into these unknown areas in a way that still maintains our preferences. Ontological crises are exactly when models of physics splinter. Various approaches at conservative behaviors like quantizing, the main problem with them is when should we be conservative? It's not clear, and model splintering give a very good time to be conservative. The basic concepts we used are now starting to come apart. Now is the moment to be cautious. The Goodhart problems, which are basically that if you motivate people by a measure, it is no longer becomes a useful measure. Like if you want to count how many, if you want to get an idea of how much, of how many nails your factories are producing, you can just count the nails. But if you motivate the managers of the factories by the number of nails they produce, they will start producing tiny metal shavings that technically count as nails. So what happens is that it used to be that the measure we're using and the desired behavior were the same, but now those are splintering. Similarly, wireheading, where the AI takes over its own reward channel, is again a splintering between the reward channel and the desired behavior, which used to be aligned and now are no longer. Out of distribution behavior is the current ML version of this problem. Low impact can be said as, well, we want the features to be similar to what they were before. Underdefined preferences are the examples I've been harping on in this presentation. Things like active inverse reward design, these are often phrased as unclear reward, but I prefer to see it as a very clear reward over unclear features. And in a sense, the whole friendly AI problem is that friendly is well defined in typical situations. We can get a bunch of situations where we'd say, okay, this is the nice thing to do. That's what we want the AI to do. And we want to extend that, this is the nice thing to do in this situation, to some general friendliness across all situations. Anyway, thanks. And I also want to mention that the future can be worth it because the same things that make AI potentially very dangerous, if they're very powerful, can also make them extremely positive. If they are aligned with human preferences. So thanks for listening to the talk.
Thank you so much, Stuart, for coming to talk to us. If you wouldn't mind, I'd love to just ask you a few questions if you have some time. So I wanted to start off with, from my understanding, your model splintering sort of argument says that when an AI goes out of distribution, we need a way to kind of rebuild its worldview, and you've discussed this in your talk. But do you have any sort of teasers towards a sort of method which we might use towards that goal?
Sorry. Well, the first thing is that humans seem to be able to do it. That communist Croatian Yugoslav nationalist, they generally sort out what their preferences to follow. They might choose one of the three trends, or they might keep the other ones as an ideal. But we can cope with this transition. In fact, that's essentially what maturing is. When you realize that the picture we had before was oversimplistic, and then we have to figure out, well, what do we really value the personal pain? Do we really value the liberty? What happens when these things are in tension? So philosophical investigation can be seen as coping with this. The other aspect is that to some extent, it doesn't matter all that much. As long as things don't go disastrously wrong. So if there's some issue that I hadn't thought deeply about came out, like historical justice or something like that. I haven't thought deeply about it. I don't really know the arguments. I'm pretty sure that people could convince me of different things on historical justice, depending on which presentation I heard first. And it might get stuck, and then it would be hard to change, and it would become my actual opinion. And it doesn't really matter, in a sense, because both of them are compatible with my current starting point, or both. There's probably lots of different opinions. And so if I end up in one or the other, it doesn't matter too much to me. If I end up as a neo-Nazi, that would be bad for me. So there's a lot of slack in the system, but there are some things that we don't want. So the part of the thing is to do that transition that in a way that we don't get the things that we don't want, and not focus too much on getting absolutely perfect in every way in the ways that we do want. And yes, I've just and it's the main, I mean, one easy way, is take all the features that co-vary, notice when they start splintering, notice when liberty and happiness come apart, for example, and weigh them all equally, or weigh all the reasonable ones equally, and disentangle reasonable. There's a huge amount of weight in that word, but you can you can maybe start getting some human feedback. But if you weigh them, if they splinter and you weigh them equally, then you get something that works decently well. And that's the aim of this. So if you want, my program is wildly ambitious. I want a friendly, aligned superintelligence, but the success criteria are not very strong. I don't need any perfection. I need an adequately safe superintelligent AI.
Fantastic. So going back to basics, in order to get to a situation where you have an agent and its model is splintering, you need to start with some kind of reward function or utility function. Now, just so we're clear, what's the sort of best way to go about this? Because you've just spoken about the fact that humans have this ability to sort of, once their understanding of the world breaks down, they have this ability to sort of build another one back up again, which we want to instill into AI. So if we build reward functions in kind of the same way that you know, judge based off humans, so with some kind of inverse reinforcement learning or something, do you see that as a more viable sort of strategy compared to, say, handcrafting a reward function for an agent? Or which one's going to lead us to sort of which is going to be a more fruitful avenue for us to go down? Can we trust agents to learn off irrational humans so that they can sort of get an understanding of the world, or is there a better approach?
Well, first of all, why I'm looking for reward functions in the first place and utility functions, it's not because I particularly have deep philosophical commitments to them. It's that others' form of preferences seem to be unstable, mostly, and tend to converge towards a reward function or a utility function. And rather than getting some other system and letting it randomly walk towards a close utility function or reward function, I say, well, let's do the hard work to get it in that form anyway. Then, yeah, so IRL, inverse reinforcement learning, definitely has its place. In fact, a lot of what I'm doing is been working with IRL and seeing how to make it work. The problem with IRL is that humans are not fully rational in every single action we've ever done in our entire lives, hard though it may be for you to accept. And it turns out that when the agent is irrational, it is impossible. There's a no free lunch theorem that you cannot figure out their rationality without knowing their preferences, and you can't figure out their preferences without knowing their rationality. And most no free lunch theorems just go away when you apply simplicity to them. This one doesn't. The simplest explanations of human behavior are that we are fully rational in everything we've done, we are fully anti-rational in everything we've done, or we have no actual preferences. I have a paper in Eurips about that. It's rather mathematical, and what's interesting is that humans can go around this very well. When we look at other humans, we don't have this problem of interpretation. So there is a human skill or a human model in our minds which allows us to short circuit this impossibility result. And so my goal is to get this bit into the AI, and then IRL would work. And part of that, and part of what I'm trying to get, not just that bit, but the bit that applies on the model splintering. I could ramble on, but give me more questions.
If I'm understanding it sort of correctly, if you're trying to use inverse reinforcement learning for an agent to learn from humans, not only are you dealing with a faulty irrational reward function from a human, but you're also having to sort of translate this through a faulty planning algorithm as well. Like humans have this way of planning that's not perfect. We intend to do something, it doesn't work, and then after that you get to the reward function that the human has, which is also broken. So it seems like a pretty difficult problem, but I mean, hopefully somebody can figure it out, because it seems viable. So if we go back to the point you made earlier, you said that you put it at about 5 to sort of 30% in terms of global catastrophic risk from intelligent agents. I had a discussion with somebody recently, and their kind of argument put it in your sort of their objectively wrong category, where they said it was pretty much 0% that a super intelligent agent would have any impact on our lives, just merely because of the fact that they're very invested in machine learning research, and they have this idea that with the technology we have today, in the wrong hands, there's a very small chance we're ever going to get to the point where we're developed enough to engineer intelligence on a level of our own. Do you think that that's a risk, that this naive kind of intelligence we have today is enough to do it, or do you think we need some kind of superior intelligence to really pose a threat to our existence?
Well, to answer that, the guy anyway, to answer them, I would say that you have to distinguish between in-model risk and out-of-model risk. Like, if you understand, if you say run the models of physics, and like the LHC, black hole creation, you can run the models of physics and say that the probability of this happening is 0.0 blah, 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 percent. And what this means is, at that point, forget about staying within physics. The chance of a black hole is coming from the chance that our model of physics is wrong, not from within the model. So I strongly, if someone has put such a zero, first of all, zero requires infinite probability. If it's actually zero, that would mean that even witnessing an AI slaughtering the entire human race in front of them would not shift their opinion that this happened. But even if you go towards very low things, probably they have, sorry to pick on you, anonymous person, but a model of what's possible and what's not possible. And within that model, the probability is very low. But then the actual probability is what's the probability that their model's wrong? So what is the probability that we can get some super intelligent behavior or some superpowers from current technologies or from near future technologies? I mean, it seems unreasonable to put it at very, very low. The AIs already can do in narrow areas extremely can do better than humans, vastly better than humans. There we have general methods for training. We don't have a general intelligence, which is very interesting. This is not what people were expecting in the 80s and 90s. We've solved self-driving cars and things like that without using general intelligence. So we don't have general intelligence, but we have things that are tending toward that direction. And if you imagine into the future, you could definitely say that this might lead to an actual general intelligence. And then there's the seed AI argument. If you have something that looks like a human inside a machine, then suddenly it can apply its own understanding of itself to conquering new areas. Just like imagine that there was a small group of humans in the Roman Empire and you gifted them with all the technological and other knowledge of today in an easily accessible format. They could transform this knowledge into power. Even though they're human, they're still physically the same as other Romans. So then this seed AI might be able to unlock all these cognitive abilities and blah, blah, blah. The point is, I'm not saying that this is going to happen or that's necessarily likely. I'm just saying that to be sure that it's not going to happen requires a lot of certainty, and this certainty has to come from somewhere, and no one that's presented that has levels of certainty that I've seen in this area has presented anything like the sort of thing that would be required for that.
This person has definitely got strong opinions, so maybe seeing the population slaughtered in front of them, that might do it for them. So you mentioned general intelligence there. You spend a lot of your time sort of trying to deal with trying to direct general intelligence towards something productive and something safe. But what's your kind of opinion on how that general intelligence is going to arise? Do you ever think about what sort of avenues I don't know if you've heard of systems like OpenCog or things like that. Do you see any sort of viable solutions to that problem that exists now? Or where do you see which avenue of research is going to get us towards a goal? What's your opinion on that?
Well, I do, and I speculate on it, and it's fun, but I don't put too much effort into it. I've put enough effort to sort of realize that whatever approach that is plausible today happens, there's a chance that my research could help with that. So, and if things happen unexpectedly early, well, I'm still going to do my research as fast as I can. I basically realized that I didn't need to worry too much about what avenues would happen and when it would happen, because I'm operating basically on the assumption that it'll happen soon and that it'll be very powerful. Because if I can solve that problem, or if humanity can solve all that problem, then we can solve the much easier versions of it. OpenCog is fascinating because it's so disastrously not working, but I think it has a certain potential because there's a syntax. I have a syntax versus semantics post on Less Wrong and symbol grounding, and it seems to me that, well, OpenCog is not working because basically they don't have symbol grounding. properly. And I know symbol grounding's an old-fashioned AI idea, but there are ways of phrasing it in terms of modern machine learning that I'm working on. But it might be that just a little bit of symbol grounding, suddenly OpenCog goes from practically useless to, wow, it understands everything. I have a sort of analogy of if you have an encyclopedia in a language you don't know, like Linear A, and you have a small Rosetta Stone. If the Rosetta Stone is enough for you to translate the language and then extend that translation through the encyclopedia from context, then suddenly a small piece of information has unlocked um, a vast database and made it useful. And that might happen with OpenCog.
So moving from kind of artificial general intelligence and its creation towards like the meta work that you do in its sort of safety, there's a couple of avenues that we might be looking at. We discussed one before the call, of iterative distillation and amplification, I believe, and there's also the theory of sort of utility indifference, and there's a couple more that are maybe more viable than others towards reaching this kind of, as you put it earlier, sort of benevolent superintelligence that acts in our best interest. This aligned superintelligence. Which kind of do you think this is a case of needing sort of all of these approaches together, or is there one that seems more viable than others at the moment, or where are we kind of in this research towards alignment? That's a big question.
There's different approaches, and I'm happy that people are pursuing different ones. Like there's a guy called Alex Turner. He's researching various quantifications of the power of AI. It's sort of a low impact approach, so that can you control AIs that way? I think he's going to fail. I am pretty sure that he's going to fail. However, I am very happy that he's doing the research because there's a chance that he won't. And if it doesn't, the result will be great. Basically, I'm pretty sure that a lot of approaches are going to fail, but I'm also pretty sure that the approach that succeeds is probably going to be one that I currently think is going to fail, if that makes sense. So pursuing lots of different avenues is good. And what I like about the model splintering approach and the work I've been doing on IRL and things like that is that it seems to me that it can be slotted in. Results here can be slotted in to many different methods and improving them.
Sure. So you said something interesting there, which was not if one of these methods succeeds, but when. You seem optimistic that something will work sooner rather than later, because to me it looks like almost an intractable problem, because how do you cage something more intelligent than yourself? It doesn't seem like logically doesn't seem like something that's possible. But you seem to think, judging by your phrasing there, that this is something that humanity will crack.
Yes, I think well, again, because remember that 5 to 30%, so it's definitely not a sure thing. But I expect that humanity has a decent chance of cracking it. And part of this optimism is basically following on what I've been researching. The problems that seem so vast and intractable now seem potentially solvable. I can kind of mentally sketch out a successful AI project, a successful aligned AI project in my mind, using methods that exist today. Yeah.
Sure. Just a couple more questions. Firstly, I want to hit you with one from some other research that you did. I found it was kind of off topic, but in your paper, "That Is Not Dead, Which Can Eternal Lie? An Alternative Answer to the Fermi Paradox," which is a very fun read. I really enjoyed it. You proposed that at some point that technologically mature civilizations might decide that I like this phrasing, they've seen it all. Like they've kind of experienced everything the universe has to offer. They've discovered the bounds of of knowledge itself. And thus they have good reason to sort of aestivate or hibernate long into the future until their sort of resources can be better spent. So, do you think it's possible? Do you think this is actually a possibility that one day a species could have sort of seen it all or maximized their knowledge, and B, could it be a biological descendant of biological or machine descendant of humanity that does it? How will they know that they've reached these sort of maximum levels of knowledge and understanding that the universe has to offer?
Well, let me be a bit honest about that paper. That paper, at least for me, I'm not talking for my co-authors, the scenario proposed is not a solution to the Fermi paradox. It's there mainly for look at this cool idea
Okay,
um, and that might happen and its potential future for humanity to think about. But the reason that it's not a credible solution to the Fermi paradox is because even if your main civilization is sleeping, you would leave a robot or an automated resource gathering system around to stop gas escaping, to stop stars being ejected from the galaxies, maybe to colonize nearby galaxies and send back their resources as well. So there's no particular need for everything to wait that long.
sure. So much to my dismay, not a viable solution to the problem. Okay, well, heartbreaker. But I want to finish off with just a couple of more. So there are a lot of undergraduates listening to this now, and a lot of PhD students who are fascinated, I'm sure, by what we've discussed today and the kind of the work that you do. And I was wondering if you had any
I
sort of.
wish I could see them.
I wish you could see them. They're all watching on YouTube. I'm sure that they're you can just imagine them there. So I was wondering if you had any practical advice for them. How can they, if they're interested in what you've been talking about and the research that you do, how can they practically contribute to solving the problems that you're trying to solve?
Hmm.
And how can they kind of get some momentum rolling into that direction of which seems like quite an abstract field and quite a difficult one to get into?
Well, what I'm trying to do currently is to translate these quasi philosophical problems, like you can't learn preferences without learning rationality and vice versa. Basically, it's a philosophical point into as close to practical computer science as I can. So there, for example, I bridged it down to mathematics and and I'm working with some people to try and do the next step and use it in actual algorithms and that kind of thing. So it's a if you're in so it's more a question of bridging. And I gave the example of symbol grounding, which some people think is an esoteric philosophical problem. This wasn't helped by the people who wrote on symbol grounding um, from the time. And it's definitely not helped by Searle and his Chinese room because, oh, I've read Searle and there are so many good insights in the papers, but nobody pays attention to them because he goes on about the Chinese room and it's all wrong. And it's obvious that it's wrong, even though people don't see obviously why it's wrong, but they feel that it's wrong, so they don't listen to the actual insights that are in. Sorry, private rant. But anyway, so taking some of these philosophical ideas and translating them into computer science. And maybe from the other perspective, when you're in computer science and you encounter problems, issues, can you put them in a more general category that can connect with that? So building up and building down.
Maybe including artificial intelligence or one of its facets in their research at their master's thesis or sort of third year project or PhD is a good way of having some sort of hands-on time with these ideas and having the opportunity to translate them and work with them. So on that note, I
I
want
mean,
to, well, no, carry on.
Normally, well, I would recommend people read my posts, blog posts on Less Wrong. But the problem is that I tend to write as I think. So after I finish the post, I generally have a good understanding of the idea, but that's not always clear in the post. But I do think that the model splintering um, post is worth seeing, as is the symbol grounding one, and seeing how they can be developed in practical ways.
I know I would definitely recommend at least the splintering one until you get to about halfway. The math kicks in. If you're a maths or computer science student, you should be okay. But it's the first half at least is incredibly enjoyable reading. If that's I think that's everything from my end. I want to say thank you so much, Stuart, for coming along and talking
And
to us today.
people who are watching, feel free to send me questions. I think my email is publicly available.
It is. That's how I got in touch with you. We'll send out your email to people that were watching, and if they have any questions, they'll I'm sure get in touch because I know there's lots of people from my discussions that are interested in hearing what you have to say. So thank you very much. I want to just quickly mention that if you were interested in today's discussion and you're not involved in Warwick AI already, check out the links in the description below. We have a Discord chat where we talk about our ideas. We have a Facebook group where you can come and get to know our events, our projects, our careers team, and everything else. Stay tuned for our next events, which are happening next term, in which we're going to have students discussing their AI-based projects to the audience, and hopefully more professionals like Stuart, including one of Stuart's sort of colleagues, Paul Cristiano, hopefully, is going to come and speak to us. So thank you very much, and that's everything from us. Goodbye.
Goodbye, and thanks.
If you just hold